Hello everyone, this is part 1 video on past year NEET questions from the topic electrostatics and capacitors. So both as per the NCERT syllabus, the first and second chapters in plus 2, right? Those put together, we are going to look at the past year NEET questions. We'll start with a question that has come in the year 2019 NEET paper. A hollow metal sphere. Metal sphere means what? This is a conducting sphere. So hollow metal sphere of radius capital is uniformly charged. The electric field due to the sphere at a distance small r from the center. So because of a charged sphere. But the thing is what? Here it is a conducting sphere. Now conducting sphere, if we provide charge to it, right? Charge will be residing only on the surface of the sphere. If it is a non-conducting sphere, means charge will be in the entire volume or the bulk. But this is a conducting sphere, right? So charge will be only on the surface. So the electric field produced by a conducting sphere will be similar to the field produced by a spherical shell. So whatever is the type of electric field a spherical shell will produce, conducting sphere also is going to produce the same amount of electric field. So let us say Q is the charge given to this conducting sphere, and as capital R is the radius. If you take a point outside, electric field will be different. If you take a point inside, electric field will be different. Point inside for a spherical shell or even for the conducting sphere, electric field will be 0. Electric field will be there only if the sphere is made up of non-conducting material. Outside, what is the expression? It will be 1 by 4 pi epsilon naught q divided by small r square. What is small r? Distance of the point from the center of that sphere. So what do we see? Inside means what? When the distance of the point that we are measuring the electric field is less than the radius, that represents the points inside. Outside means what? The distance of the points from the center of the sphere will be more than the radius. So look at this. What is the correct option? 0, as the smaller value is increasing for smaller less than capital R, means we are looking at the points inside, all the inside points. Wherever we mark the point inside, everywhere the field will be what? 0. And outside, we'll see what is the relation. The outside, electric field outside, right? It is inversely related to the R square. Means as the R value is increasing, right? The field value will be what? Decreasing, because R square is in the denominator. So outside, the smaller value will be increasing, which means what? The field will be decreasing. Okay, so what is the correct answer for this? It is option C. So we must remember the electric field function due to the spherical shell as well as due to the non-conducting sphere. Okay, so non-conducting sphere means inside also we'll have the electric field function. Okay, so these relations are important because quite a number of years, right, we got straight questions, either like this one, analysis of the formula, or we even got I think in some of the medical entrance examinations, graph based questions also. We'll move on to the next question. This is a question based on the force formula. This has come again in the NEET 2019. 2 point charges A and B having charges plus Q minus Q respectively are placed at a certain distance apart. Means they are not even telling us what is the distance. And force acting between them is F. So what is the force acting between them? Force means the magnitude of the force. What is it? F. If 25% of the charge A is transferred to B, then the force between them becomes how much? So here we have a plus Q here, that is our A, and minus Q, that is the B. They are at some distance apart. They are not giving what is the distance. Let us say the distance is D. So what is the initial force expression? It will be what? K into modulus of the first charge, modulus of the second charge, divided by distance square. Okay, so this is our F. Now second instance, what we are doing, 25% of the charge of A. See, what is the charge on A? Q. 25% of this means how much? Q into 25 by 100. That is what? 25 ones, 25 fours. Q by 4. So from here, Q by 4 is taken and given to the B. Look at this. What is the new arrangement? From here, from Q we have taken Q by 4. Remaining will be what? Q minus Q by 4, 3Q by 4. What about the case of B? B minus Q is the original charge. We are adding plus Q by 4, right? Now look at what is this. Minus Q plus Q by 4 means what? What is it? It will be minus 3Q by 4. That is the charge of B. Now let us say the force is F dash. K into modulus of the first charge into modulus of the second charge divided by D square. So what is the distance is not changing, by the way. So what do you have? 3 by 4 into, this is also modulus means only the absolute value will be taken, right? So 3 by 4 into 3 by 4 is what? 9 by 16 into KQ square by D square. What is this KQ square by D square? F, right? From equation 1. So 9 by 16 into F, that is our F dash. The new force between the charge A and charge B will be equal to what? 9 by 16 times the original force F. Correct answer is option C. We'll move on to the next question. This is another straight formula based question based on field due to infinitely long charged wire. Two parallel infinite line charges having linear charge densities plus lambda and minus lambda means what? One of them is having a positive, other is having a negative, are placed at a distance 2r in the free space. Means what? Like this, say for example we have one, this is having what? Plus lambda. This is infinite, though diagram we'll have to end it somewhere, but what is this line? This is an infinitely long charged wire. Other is what? That is also infinitely long charged wire. Both are parallel, by the way. So what is the charge on this? This is minus. Okay, what is the separation between them? It is given as what? 2r. They are kept in the free space. Okay, means the permittivity we have to take it as what? Permittivity of vacuum or free space. That is why they have mentioned even that they are kept in the free space. Okay, what is the electric field midway between the two line charges? Midway means what? Exactly from this it will be distance r, from this side it will be distance r. Now remember, the infinitely long wire, both the positive wire as well as negative wire, both of them will produce electric field there. The electric field produced by the positive wire will be what? It will be perpendicular to the wire but away. This is the field produced by the wire having positive charge density. What about the field produced by the wire having negative charge density? That will be towards the wire, perpendicular to the wire, towards the wire. So we'll see that both of them will be in the same direction. Both of them will be in the same direction. But what about the field magnitudes? Field magnitude will be what? It will be modulus of lambda by 2 pi epsilon naught into r. That will be the field magnitude for both of them. So for the negative charge also, what is it? Modulus of minus lambda. In one case it will be plus lambda, other case it is minus lambda. Since we take a modulus, the magnitude will be same for both of them. You can see both the wires are having the same linear charge density. It means the electric field magnitude will be same in both the cases. They are in the same direction. So the total electric field will be what? Their magnitudes are what? Lambda by 2 pi epsilon naught into r. This also is what? Lambda by 2 pi epsilon naught into r. Both are in the same direction. So means what? Both the magnitudes we will simply have to add. Both the magnitudes we will simply have to add. What is it? It will become what? Lambda by pi epsilon naught into r. That is the total electric field. So here we will just have to remember the electric field because of the infinitely long charged wire. That formula we are able to remember means this question we will be able to answer. And one more thing about the direction. the field directions. Okay. Next we go to a question that has come in the Odisha paper 2019. Two metal spheres, one radius capital, other radius 2r, respectively have same surface charge density. Remember, metal spheres means this is the conducting, like the way we have seen in the first question that has come in the 2019 paper. Conducting sphere means what? Charge will be only on the surface. That is why for the conducting spheres, right, we will define what? Surface charge density. Both of them have the same surface charge density sigma. They are brought in contact means what? We first bring them into contact and separate. They are brought in contact and then they are separated. What will be the new surface charge density? So if you look at these options, right, they are giving these options in terms of the original surface charge density, which is sigma. So what is happening here? Let us just try to understand. There is a smaller sphere, radius r, bigger sphere. They may not be looking perfectly like a sphere, but assume it like a sphere. Okay. This is having a surface charge density sigma. This is also got the same surface charge density. Both of them have the same surface charge density. So if you want to know what is the charge on this, what is it? Area, surface area is what? 4 pi r square. What is the charge on this one? Surface area is what? 4 pi into what is the radius here? 2r. 2r whole square means 4r square will come. Totally what is it? We'll see. The bigger one is of course having a larger amount of charge. Now when we brought them to contact, what is going to happen? There could be some charge transfer. There could be some charge transfer. That is what we call as a charge realignment or redistribution. Now this realignment will happen till the potential values on both spheres will be same. Because charge transfer is going to happen till both the spheres are having the same potentials on the surface. So here we don't know how the charge redistribution can happen. For that, what we will be doing is, let us look at just the total amount of charge. What is the total amount of charge? Here 4 pi r square into sigma. Here 16 pi r square into sigma. Total means what? On both these spheres put together, what is the total charge? 4 plus 16, what is it? 20 pi r square into sigma. This is the total charge. Okay. Now what we'll say is, let us say this charge is distributed. This charge is what? Distributed between these two spheres, such that the potentials on both the spheres will be what? Same. That is the condition. Because the charge distribution will happen to make sure that both the spheres are having the same potential. Correct. Now what we will do is, let us say the charge that is going on to the smaller sphere is x. The charge that will be going on to that larger sphere will be what? Total charge minus x. So this is now our q1 dash, this is our q2 dash. What is the potential on the surface of a conducting sphere? K q by r. The potential value on the surface of a conducting sphere is what? K q by r. So here for the first sphere means k into q1 dash by r. Second sphere means what? K into q2 dash by, here what is the radius? 2r. Both these values must be same. That is the condition, right? In such a way that the charge redistribution will happen so that both the spheres will have the same potentials on the surface. Because we know charge transfer or charge movement will happen when there is a potential difference. So here when we equate both of them, we can see r is cancelled, k is cancelled. So what do we have? 2 times q1 dash is equal to what? Q2 dash. Q1 dash is what? X, right? So 2x is equal to Q2 dash means what? This one. 20 pi r square sigma minus x. Bring the minus x to the left side, will become plus x, right? So 3x is equal to what? 20 pi r square into sigma. Straight away from here we will get the x value. What is it? 20 by 3 pi r square into sigma. If this is the charge on the first sphere, what is the charge density on this? Let us call it as what? Sigma 1. charge density on the first sphere. What is it? Charge value divided by surface area. What is surface area? 4 pi r square. So look at it. 20 by 3 pi r square into sigma divided by 4 pi r square, right? So pi r square is cancelled. 4 ones are 4 5s are. How much it is? 5 by 3 into sigma. That is the new surface charge density on the sphere 1. From this itself, I think we can conclude the answer. Look at this. Only one of them is matching. What is it? Our option D. Only that one is matching. We can also do the other thing. Other thing is what? Finding what is the surface charge density on the second sphere. Second sphere, what is the charge value? 20 pi r square sigma minus x, right? So which means what? Q2 dash is what? 20 pi r square sigma minus x is what? 20 by 3 pi r square sigma. What is it? Take an LCM. 3 20s are what? 60. 60 minus 20 means 40. So 40 by 3 pi r square sigma. That is the charge. So charge density here, sigma 2 will be equal to what? Charge divided by surface area. What is surface area? 4 pi into the radius square. What is the radius? 2r. So totally what is surface area? 2r square means 4r square, right? Which is what? 16 pi r square. That is surface area. Pi r square is cancelled. 8 2s are 8 5s are. So denominator already there is a 2 and one more 3 will come. What is it? 5 by 3 into 2 means 6. You can check it. What is the answer? 5 by 6 into sigma. So here to solve this question, right, what is the basic idea we are using? We are using the idea that once we touch both the spheres, the charge redistribution happens in such a way that both of them will be having in the final state same potential. So here we should remember the formula of what is the potential on the surface of a conducting sphere. Potential on the surface of a conducting sphere. What is the formula for that? It is what? K Q by R, where Q is the charge on that conducting sphere, R is the radius of the sphere. Next we have a question again that has come in the Odisha paper 2019. This is based on the capacitors. Two identical capacitors C1 and C2 have equal capacitance. Means both of them are having what? Equal capacitance. And are connected as shown in the figure. So there is a circuit that is given. Terminal A and B of the key are connected to the network like this to charge the capacitor C1 using the battery of EMF V volt. Means what? Look at this. When you connect the A and B terminals, what is happening? We are able to complete the circuit where there is a battery and there is a capacitor C1. So what is going to happen? The capacitor C1 is going to get charged. It will be charged till the potential on the capacitor will be equal to the potential of the battery, correct? Now disconnecting the A and B terminals, B and C are connected. Means what? Maybe we can just draw it. Once the capacitor C1 is fully charged, right? We disconnect the B from A and we connect B and C. Now we will see that this C2 is what? Initially uncharged. This one is charged because now only we have charged it by using the battery, right? When you connect B and C means it is like what? The C1 and C2 are connected across. It is like they both are in parallel. They both are in parallel, or we can also say what? They both are connected across. Due to this, what will be the percentage loss of energy? They're asking, by connecting the capacitor C1 across capacitor C2, what will be the loss of energy? It's a very standard question. In fact, this same model of question is there also in the NCERT textbook itself. It is given. So what is happening here? In fact, when we have charged this capacitor C1, by the way, C1 and C2 are identical. Let us say the capacitance value is C. Both of them are identical. So both of them will have the same capacitance C. Now initially we are charging this by connecting across a battery, right? So after fully charged, the potential across the capacitor 1 will be what? V. So charge on this will be equal to what? C into V. So if the capacitor is getting a charge Q, what will be the Q value? C into V. Now when we are connecting it across this uncharged capacitor, what is going to happen? Essentially some charge flow will occur. Charge flow will be happening, right, from C1 to C2, and this charge flow will happen in such a way that finally the potential across both the capacitors will be same. Charge flow will happen in such a way that potential across both capacitors will be same. That is the basic principle. But here we have even more simple arrangement. Why? Because C1 and C2 are identical. If the charge on the C1 is Q, the charge will be redistributed in such a way that both of them will end up having equal charges, because when they have equal charge means potentials on them also will be equal, right? For identical capacitors, when they are having equal charge means what? Potentials on them also will be equal, because what is the potential across the capacitor formula? Charge by capacitance, right? So the total charge Q that is available initially on the capacitor 1 will be distributed how? Q by 2, Q by 2, like that. Now they are asking what will be the percentage loss of energy. So here the initial energy, initially only the capacitor 1 is having energy. What is the energy formula? It is having a charge Q, means energy is what? Q square by 2C. That is the initial energy. Finally both the capacitors are having charge, each of them Q by 2, correct? So the energy on the first capacitor will be what? Charge square by 2C. Energy on the second capacitor is what? Charge square by 2C. So if you look at it, right, what is it? The final energy Q by 2 whole square means what? Now that's it, we have got the answer. So we are trying to relate the initial energy to the final energy. So initial energy is what? Q square by 2C. Initial energy will be only on the first capacitor. Finally energy will be existing on both the capacitors because both are charged now. But you see, what is this? Q by 2 whole square means what? Q square by 4. So this is the final energy, right, will be equal to what? Q square by 8C plus Q square by 8C. How much it is? Q square by 4C. So what do we observe here? This is exactly half of the initial energy. So initial energy is what? Q square by 2C. Final energy is what? Q square by 4C. Half of the initial energy means what? The percentage energy loss. So how much energy is lost? The final energy is half of the initial energy, means the energy lost is what? Q square by 4C. Amount of energy is lost. That is why the remaining is only Q square by 4C. Initial energy is what? Q square by 2C into 100. The amount of energy lost divided by initial energy into 100, right? So what do we get here? Will be what? 50%. I mean, we don't even need to do the step. We can just conclude by looking at the values itself, right? If the final energy is half, means how much is lost? 50% is lost. So here the thing that has helped us in calculating is that the capacitors are what? Identical. That is why charge will be distributed equally. But the basic principle is what? When the charge is distributed onto the capacitors, like in this kind of arrangement, right? When C1 and C2 are redistributing charge, the redistribution of the charge happens in such a way that the final potential values on both capacitors will be same. That is the basic principle. Okay, that we need to keep in mind. The basic principle is what? The final potential on both the capacitors must be same. Mostly if you look at the recent year NEET examinations, right, we get questions on these identical capacitors. Identical capacitors means, I think in 2017 also we got a similar question. Okay, so identical capacitors means what? Whatever the charge that is there will be equally distributed. We'll move on to the next question. This is a question that has come in the NEET 2018 paper. An electron falls from the rest through a vertical distance h in a uniform and vertically upward directed electric field. How it is falling? Electron, right? Electron is what? Negatively charged. It is falling how? In an uniform and upward directed electric field. Remember, the negative charged particles will experience a force in the direction opposite to the electric field. If you look at electric field is upwards, right? Force acting on the electron will be what? Charge of the electron into electric field. We can see the force will be exactly opposite to the direction of electric field. What is the force magnitude? You take a modulus. It will be equal to what? Small e into capital E. That is the force magnitude. So we'll see if the applied electric field is upward, means force acting on the electron will be what? Because of the applied electric field, downwards it will be opposite direction. And already electron weight will be acting downwards. Mass of the electron into g. So total downward force. Net force acting on the electron is what? The force because of this applied electric field plus the gravity. Both are in the same direction. Because of this, the acceleration will be what? Net force by mass. Here we can see if you split it, means what is it? Small e. Small e is what? Basic charge. Small e into capital E. Capital E represents the electric field strength divided by mass of electron plus g. So let us keep it. The downward acceleration is what? Small e by mass of electron into capital E plus g. Okay. The direction of the electric field is now reversed. Means we are reversing the direction of the electric field, keeping its magnitude same. A proton is allowed to fall from rest in it through the same vertical distance h. First case we are allowing the electron to fall. Second case we are allowing the proton to fall. The time of fall for the electron in comparison to the time of fall for the proton. You have to compare the time of fall for both of them. So since they are falling through the same vertical distance, right? Starting from rest means initial velocity is 0. The vertical displacement is same for both of them. For the electron also we are considering the same vertical fall of h. Proton also we are considering the same vertical fall of h. Time taken will depend upon what? Time taken will depend upon the downward acceleration. Wherever the acceleration is higher, time will be what? Less. Now look at this. We talk about the proton. Proton, what about the charge? Same. Basic charge. Now here we are reversing the direction of the electric field. Initially the electric field is what? Vertically up. Now the electric field is down. Same value. Here positive charges will experience a force in the direction of the electric field. Means the force because of electric field will be downwards. What about the magnitude? Same. And of course the proton, right, will have its mass. Remember, mass of the proton will be more than mass of electron. How much? Approximately 1836 times the mass of electron. This is something that you would have learned in chemistry as well as in modern physics chapters also. We will talk about the relation. So the weight acting on the proton will be what? Mass of proton into g. So total downward force in this case is what? Gravity plus the force because of the applied electric field. Both are in the downward direction. From this, what is the acceleration? Force by mass. Here what is it? You see, the acceleration in the case of electron we already got it. Acceleration in the case of proton, what is it? E by mass of proton into capital E plus g. Now they are falling through the same vertical displacement. They are falling through the same vertical displacement. Look at it. So if you have the initial velocity is 0, then displacement is equal to what? Half a t square, right? Displacement is equal to what? Half into a into t square. So wherever, so we look at this relation. So both are falling through the same vertical. So both are starting from rest. Both are falling through the same vertical displacement h. Initial velocity is what? 0. So What is the relation? Displacement is equal to what? Half into A into T square. Correct, because the initial velocity is 0, right? Normally, what is the displacement formula? S is equal to ut plus half at square. So wherever the acceleration is more, the corresponding time will be less. Now if you look at these expressions, right, G is common in both of them. Let us keep it aside. This term is the critical one, that basic charge into applied electric field value divided by mass of electron. Here what is it? Basic charge into applied electric field will be mass of proton. We know the relation. What is it? Mass of proton is a higher value than mass of electron. Means the second case denominator value is higher. Means the acceleration of proton will be what? Less. Acceleration of electron will be what? High. When the acceleration of electron is high, remember, when the acceleration is high means corresponding time will be what? Less. So look at the question what they're asking. The time of fall for the electron in comparison to the time of fall of proton. So what we can say, definitely the time will be what? Smaller, because in case of electron, right, the acceleration is what? High. When the acceleration is high means the time of fall will be what? Less. So this question, part of it is about getting that acceleration expressions, and then next we have a question that has come in the NEET 2018. The electrostatic force between metal plates of an isolated parallel plate capacitor C having a charge Q and area A is, means we need to find the force between the plates of the capacitor. So generally the parallel plate capacitor, we will consider the plates to be made up of non-conducting material. Okay, so if in this question, of course, they have mentioned the word metal plates, but the final result will not be changing. So if you have say a conducting material or non-conducting material, this is what? A parallel plate. Now each of these will have charge Q. One will have a plus, other will have a minus. Area of cross section is same for both of them. So we need to find the electrostatic force between them. So plate 1 and plate 2, let us say. Plate 1 will develop electric field everywhere. So the value of the electric field, if you assume it to be non-conducting, then the value of this electric field will be sigma by 2 epsilon naught. Sigma is surface charge density, which is Q by A. That will be equal to what? Q by 2A into epsilon naught. That is what is the field developed. And this field will be acting on the plate 2. So the force experienced by plate 2 will be what? Force experienced by plate 2 will be equal to what? The field multiplied by charge on the plate 2. I mean, we'll just look at the magnitude of the force, means we'll take the modulus of the charge, right? Which is what? Q square by 2A into epsilon naught. So here we have assumed that the plates are what? Non-conducting. That is the general assumption for the parallel plate capacitor. If you assume that to be conducting or metal, right, then what we'll get? The field developed by the first plate, in place of sigma by 2 epsilon naught, it will be what? Just sigma by epsilon naught. So accordingly we will get the force as what? Q square by A into epsilon naught will come, the final force. But if you look at it, the force, right, is not depending upon the distance between the two plates, because for a parallel plate capacitor, which we assume it to be large enough, the field will be coming as what? Independent of the distance from the plate. So as a result, what do we see? The force of attraction, in this case the force will be what? Attraction. This is plus, this is minus, they will attract. The force of attraction will be what? Independent of the distance between the plates. So look at it, what is the correct answer? It will be independent of the distance between the plates. What is option B? Linearly proportional to the distance. Option C is proportional to square root of the distance. Option D is inversely proportional to the distance. It does not depend upon the distance. It will be what? Independent of the distance. Okay. Next we have a question that has come again in the NEET 2018 paper. This is a question that is linked to both the electrostatics and the kinematics, 1D motion. Toy car with a charge Q moves on a frictionless horizontal plane surface under the influence of a uniform electric field E. Due to the force Q into E bar, its velocity increases from 0 to 6 meter per second in 1 second duration. Means, say for example, it is starting from here, t is equal to 0. In the first second, it is increasing from where? 0 meter per second to 6 meter per second. Means we can find what is the acceleration that is generated. What will be the acceleration that is generated? Change in velocity divided by time taken. That is what? 6 meter per second square. So the applied electric field is developing an acceleration of 6 meter per second square. Okay. Velocity is increasing means initially the acceleration is towards the right side in this case. At that instant, the direction of the field is reversed. So it means what? T is equal to 1, the direction of field is what? Simply reversed. Then what is going to happen? The toy car will experience same amount of acceleration but in the reverse direction. So we call it as what? Retardation. The car will continue to move for 2 more seconds under the influence of this field. Means what? The car is going to move under retardation. The average velocity and the average speed of the toy car between t is equal to 0 and t is equal to 3 seconds. Look at it from here, right? It is going to move under a retardation. Same 6 meter per second square, backward direction. Initially what is it? 6 meter per second square in the forward direction. Now the acceleration is what? 6 meter per second square in the reverse. So this is under deceleration now. Deceleration means here the velocity is what? 6 meter per second. You know when the velocity is going to become 0? The velocity will become 0 if you start the journey here, right? Initial velocity 6 meter per second. Deceleration is what? Minus 6 we have to take as per the sign convention. Remember the sign convention that we follow in the kinematics. So look at it. So this calculation step is over. So let us just erase it. Now look at it. What is it? The final velocity is 0. Initial velocity is what? 6 meter per second plus acceleration is what? Minus 6 into t. So from here we will get minus 6 is equal to minus 6 into t. So t is equal to what? 1. Means what? From that point, after 1 second, the velocity is going to become what? 0. Which means already we are at t is equal to 1 second. From that time, 1 more second means what? We will come to t is equal to 2 seconds, right? So from there, it will keep moving in the forward direction till t is equal to 2 seconds. Then what will happen? It will reverse. It will reverse its direction because there is an acceleration in the reverse direction, right? And due to symmetry, what we will see is it is taking 1 second to go forward, means 1 second it will end up at the same point. In 1 second it will be ending at the same point because the total journey time is what? 3 seconds, right? T is equal to 0 to t is equal to 3. So by symmetry principle, from t is equal to 1 to t is equal to 2, it is going some distance. T is equal to 2 to t is equal to 3, it will end up at the same point. So here they are asking us what? The average velocity and average speed. Average speed means what? We have to find what is the total distance covered and divide by the time taken. So total distance covered will be what? Here, look at this. This t is equal to 0 to t is equal to 1. In that time, let us calculate what is the displacement from the kinematics equation. Okay, how do you find it? Initial velocity is there, final velocity is there. We have acceleration. So what do we have? V square minus u square by 2 into acceleration. That is what? 36 by 12, which is 3 meters. That is this S1. We can calculate S2. S2 will be what? From 6 meter per second speed, the speed is coming to 0. Acceleration is what? Here we will type minus 6. So S2 will be what? V square minus u square divided by 2 into acceleration. Same kinematics formula. So what is it? Minus 36 by minus 12, which is what? Again 3 meters. Means this is also what? 3 meters. By symmetry, we can even try and check it up. By symmetry, S2 will be equal to S3, right? So S3 also will be equal to what? 3 meters. Okay. Now, total distance covered means what? S1 plus S2 plus S3, that is what? 3 plus 3 plus 3, 9 meters. Okay. So total distance covered is what? 9 meters. Divided by time taken is what? 3 seconds. So average speed will be what? 3 meter per second. Average speed will be 3 meter per second. Now look at it. Speed average value 3 meter per second is shown in which options? Option B and option D. Now we have to find what is the average velocity. Average velocity means what? We have to look at the displacement. So what is the displacement here? Initial point is here. This is the initial point, right? This is the final point. Displacement means what? Shortest line between the initial point and final point. What is this? This is nothing but equal to S1, right? Numerically this will be equal to what? S1, which means that total displacement of the journey is what? 3 meters. Time is what? 3 seconds. So the average velocity will be equal to what? 3 meters is the displacement, 3 seconds is the time. What is it? 1 meter per second will come. So what is the correct answer for this? Option B. So this question involves a little bit of kinematics principles also. We should be remembering them. Next we'll go to a question that is based on the capacitors. In fact, we have seen a similar model question in one of the previous years also. I even mentioned that we have a question in NEET 2017 at that point of time. Look at this. A capacitor is charged by a battery. The battery is removed and another identical uncharged capacitor is connected in parallel with the already charged capacitor. Means what? First we are taking a capacitor, connecting it across a cell or a battery. So in this case it is battery. Battery is nothing but what? Combination of cells. So if the battery is having a potential V and the capacitance is C, this capacitor will be fully charged till the potential on the capacitor is equal to the potential of the battery. Means this will get a charge Q, which will be equal to what? C into V. Now this is removed and connected across another identical uncharged. So this is having a Q, but this is having zero charge. Both have the same capacitance. Identical means what? Same capacitance. Now the total electrostatic energy of the resulting system, once we connect it, right, there will be some charge transfer from the charged capacitor to the uncharged capacitor. Charge transfer will happen till both will have same potential. But here the thing is, both are identical capacitors, right? Total charge is Q. So finally both of them will end up having half the amount of charge, because capacitance is same, right? Potential is what? Charge by capacitance, means both should have the same charge, then only both of them will have the same potential. Okay, so whenever we have like this charge transfer between identical capacitors, right, finally they will be having the same amount of charge, so that the potential on both of them will be same then. Now look at it. This is the initial situation, this is the final. Initial situation, what is the energy? Energy is there only in the first capacitor, which is what? Q square by 2C. Final situation, first capacitor there is energy, second capacitor also there is energy. Here what is energy? Charge square by 2C plus second capacitor charge square by 2C. If you look at what is it? Q square by 4, already there is a 2, means Q square by 8C plus Q square by 8C. Totally what is it? Q square by 4C. This is the final. This is the final energy. This is the initial energy. So what do we see? It is becoming half. Initial energy is what? Q square by 2C. Final energy is what? Q square by 4C. So what is it? The total electrostatic energy of the resulting system will decrease by a factor of 2. So in fact in the previous question I think they have asked us by how much percentage it will change, like that. So there the option we have marked was the potential energy will decrease by 50%. Correct. So reducing by half means what? Decreasing by 50%. Now the question is, what will happen to this energy? Because when the charge is getting transferred, right, from one capacitor to other capacitor, it is going through this wire, the connecting wire. The connecting wire obviously will offer some resistance, and there will be some heating of the wire that will happen. So due to this dissipation, right, the energy is being lost. Next we have another fundamental question comparing the relation between the gravitational force and the electrostatic force. This is the question that has come in the NEET paper 2017. Suppose the charge of a proton and electron differ slightly. One of them is minus E and the other is E plus delta E. Means what here? Electron is minus E, proton is what? E plus delta E. If the net electrostatic force and gravitational force between the two hydrogen atoms placed at a distance d, okay, the distance we have to assume is much greater than the size. So the hydrogen atoms are placed at a distance d, apart is 0, means the net force is 0. So what happens if you keep two hydrogen atoms? Hydrogen atom will have what? Hydrogen atom, we will consider the hydrogen protium isotope. That's what we have to consider generally. Okay, so which means what it will have? One proton and one electron. So if you look at the proton will have what? E plus delta E charge, electron will have minus E. Here also proton E plus delta E, electron minus E. What is the net charge? Delta E. Here also net charge delta E. So they both will repel. Electrostatic force wise they will be repelling, but they will attract because of the gravitation. Gravitational force they will attract. What is the concept they are saying? The net electrostatic force and gravitational force between the two hydrogen atoms is 0. Means what? The gravitational force will be able to exactly balance the electrostatic force. First we will look at what is the electrostatic force magnitude. 1 by 4 pi epsilon naught. So we will consider them to be like what? Spheres. 1 by 4 pi epsilon naught. Charge on this is delta E, net charge. Charge on this is delta E. Delta E into delta E divided by distance between the centers is what? D. So D square will come. This is the electrostatic force between two charged spheres. Now what about the gravitational force? Here they are saying consider the mass of the hydrogen atom is what? 1.67 into 10 power minus 27 kg. That is nothing but what? Approximately mass of the proton. Now because electron will be very light in comparison to proton mass, what will be the gravitational force of attraction? It will be what? G into mass of this hydrogen atom, mass of another hydrogen atom divided by distance square. Distance will be what? Distance between the two centers. Now net force 0 means what? Both of them must be equal to each other, right? So if you equate both of them means you can see d square will get cancelled, and if you cross multiply means we will get the relation. So we can just cancel the d square and cross multiply. If you cross multiply, what will have? Left hand side will have delta E the square, right hand side will be there 4 pi epsilon naught into G into mh the square. What is there on the right hand side? 4 pi epsilon naught into G into mh the square. Now the question they are asking is the order of delta E. They are not even asking us what is the exact value of delta E. They are asking us what? The delta E is of the order of. Means if you are able to tell approximately what is the exponential term for that, and we can see one thing in all these kind of questions, right? The options will not be close by. You see option A is what? The order is given as 10 power minus 23. Option B is what? 10 power minus 37. Option C is what? 10 power minus 47. Option D is what? 10 power minus 20. Like that, they will be quite far apart. So all that we need to do is look at it. Delta E the square is equal to what? 4 pi epsilon naught. See, 1 by 4 pi epsilon naught is 9 into 10 power 9. Correct? That is the Coulomb's constant for the vacuum or free space. So 4 pi epsilon naught means what? It will be a reciprocal of that. 1 by 9 10 power 9. Capital G. What is capital G? The universal gravitation constant. What is the value of that? 6.67 in 10 power minus 11. Everything we are considering in the SI system of unit. Then mass of hydrogen, the square is there. Mass of hydrogen 1.67 10 power minus 27, the square. Now look at the powers alone. So we'll just keep the terms aside. 6.67 into 1.67 into 1.67 divided by 9. These are the terms. What about the powers? Here 10 power minus 11. The 10 power 9 goes to the numerator, means it will be 10 power minus 9, right? So 10 power minus 9 and 10 power minus 11 means 10 power minus 20. Here already 10 power minus 27, the square means what? It will be 10 power minus 54. Totally what do we get? 10 power minus 74 will come. Now if you take a root of this, because the left hand side is what? Delta E the square. If you take a root of it, means what? That is what will tell us what is the delta E order. Means we have to take the root of this entire thing. 6.67 into 1.67 into 1.67 by 9. Root of 10 power minus 74 will be what? It will be 10 power minus 37. So we see that the order is what? The delta E is of the order of 10 power minus 37. So what is the correct answer for this? So we don't even need to simplify that numerical value. See, numerical value we have to simplify when we see that the options are very close by. But here the options are not close by, right? We will be able to broadly see that the order is what? It is in the order of 10 power minus 37. That's how we will be able to mark it. So this is about the part 1 video, and we will see in the next part.